All right, so in this next part of the problem, we're still continuing on, let's see here, this problem where we found the electric field, at the center of this square patch of size A, and this next short portion of it, and we found that electric field to be this right here, and this next short portion of it is for finding out whenever, for when A ends up being out to infinity. So basically, whenever you have that square patch right here, oops, if I can draw a little bit better, square patch right here, and these just keep jetting out all the way into infinity and then to infinity, so basically it just turns into an infinite plane. So that's why we have that A equals out to infinity. So what we can do is we can go ahead and take this, let me go ahead and take this electric field and just start working with it. And we know from previous experience and the previous problems that the electric field for an infinite plane, the electric field at a point z above an infinite plane or any distance from an infinite plane, doesn't really matter, is equal to this value right here. It's sigma over 2 epsilon naught, which is conveniently what is right here. So we expect that as A goes to infinity, this whole thing goes to 0. So let's go ahead and verify that right now. We know that, let's see here, when this goes to infinity right here, so when this goes to infinity, then we have essentially the tangent inverse of the square root of infinity, which is also known as the square root of infinity, and the tangent inverse of infinity. This whole thing right here ends up being pi over 2, right? And so we go ahead and just work through the rest of that. Just go ahead and skip through this part right here. And we have our brackets, so we have 4 pi over 2 minus 1. This is all still the z hat component. That was an ugly bracket. We can go ahead and cancel these out. This turns into a 2 right here. So this whole thing becomes a 1. And then, of course, we end up getting pi over 2 for our answer for when A goes out to infinity.